Alright guys, so I got a question. Where's it from again, Maureen?
12.6 number 20.
12.6 number 20?
Are you going to go on a little bit to explain? A little bit to explain the extra credit? There's something you receive
What's that?
other ones that
Something more. Something. There it is. Do you need something else too? You get that here? You get this?
Yeah, I should have a whole bunch of.
Huh? Oh, shit. Well. Alright guys, so page 769. Hey everybody. Every single person in this room. Section 12.6 number 20. Guys, so why is this problem? I can't solve this for y. It's even rougher than before. I can never get the y's together if they don't have the same powers, right? So if they're not like terms. So if I have like 8y squared equals y, I know to get it equal to 0, factor, do all kind of stuff, right? But here's a slightly different problem. I've got square root of y and y in the same equation. So what's a really good idea to try to take care of that?
pass all the y's.
Say it one more time.
You put all the y's in one side of the equation.
Nope.
Move y to the other side. I mean,
Nope.
8 to the other side.
No.
You got to
Divide both sides.
Yeah. So I'm going to square immediately. And it's fine to leave the 8 right where it is because I don't have to FOIL anything. If it was 8 plus square root of y, I so desperately would not want to square both sides. Because if I square both sides here, I'd have to actually do what with this? FOIL it. Holy shit. I don't want to do that. Right? So here, I wouldn't have to do that, would I? It's just multiplication, so I don't have to FOIL anything.
So 8y equals y.
Try it one more time. If I square this side, right? If I square this side, I better square that side. So for one thing, I got y squared there, right?
Yeah.
What's 8 squared?
8y. I mean,
What's 8 squared?
8 to the 64.
64. And what's the square and the square root do?
Y goes away. Set it free.
Who what?
Set it free.
Set it free.
Divide.
Then I get right back to where I was. You see that?
Subtract by y.
So now what do? I've got y squared, I got y, so I'm going to subtract 64y. I'm going to try to get it equal to
0.
so then I'm able to factor it, unfoil it. So again,
So you pass one y to the other?
when I have a square root in my equation, I eventually want to square it, to kill it, right? I want to make sure that there's nothing that would make me have to FOIL with the radical. That would so desperately suck. Because number one, that would suck, because it would take a while to do. And number two, it wouldn't cancel my radical. If I did this when I still have radicals in the middle term,
Yeah.
well, what the hell? The squaring actually just made everything worse. So if I have a square root, I want to square to set it free. And then I look, now when I get my next step, I just look at it with fresh eyes. I say, if somebody gave me this problem, how would I do it? Well, I can't get my y's together, so that means, because one's got a different power, that means I get it equal to 0 and factor. We know that process, right? It doesn't matter that I squared to get there. All that matters is where the hell am I, is here. And I know how to solve this kind of thing. So subtract 64y. Get it equal to 0. Then what do you do with this? GCF, beautiful. What normally screws people up is they try to get it like that. And hey, there we go, this is only 2 terms. It's not squares or kids. It's only GCF. Yeah.
Y out and then.
Take the y out.
If that y wasn't there, I would so very much agree with you.
Oh.
But 8 times 8 is not 64y.
Oh, well, I'm sorry. Y times y.
I'll be okay. So take a y out.
Y minus 64.
So now.
Good. So y equals 0 or 4. So let's check it. I'll check 0. 8 times square root of 0 equals 0. Check. I'm done. You guys, what? This, right? I mean, if I put a 0, both sides become 0. So that's the trivial solution is what we call it. Quickest way to make an equation equal is to make both sides equal 0. How about when you plug in 64? So you get 8 square root of 64 equals 64. Right? Is everybody with me?
Yeah.
Plug in a 64 in for y. What's square root of 64? What's 8 times 8? Check. Okay.
Both of them.
Hey, can you go over that again? Where you have or y equals 64?
So remember, if I have x plus 5 times x minus 7 equals 0, we should be at the point where you can just tell me the two answers very quickly.
And then minus 5 and plus 7.
Yeah. So that's going to be 64. And whenever the variable's by itself, it's 0. How do you make y 0? You make it 0. Right? It's almost too easy of an answer. You forget that sometimes. How are we doing? So right here, if anybody thought you should divide by y, no. You can never divide by something that could itself be 0. Because then you would be doing something illegal. I'm not allowed to divide by 0. So that's why I really, in general, cannot divide by a variable. Unless you do some careful things. I'm not going to get into it. So in general, do not divide by a variable because it could be 0. If I would have divided by y, I would have lost this answer. And that sucks because it's actually the quickest, best answer there is. Okay. All right. I like that. Minimal reaction. All right. Anything else from homework? Yes.
Number 40 from the same section.
All right. So the only way to make this this process is a little bit more difficult is to throw some more variables in it. So like, where'd it go? You said 40?
40.
I guess that's that, right?
Yes.
Yeah. So based on what we were just talking about, what should I do first?
You moved it
Minus
to
a
3.
Yeah, get that 3. And be real careful. I always get somebody, this is wrong. What I'm about to do here is wrong. I get somebody that tells me, all right, I'm going to square everything. There we go. I think you can tell from my tone that's not right. I can't just square each piece. Whenever I do to one side, I've got to do the other side. And if you do this, do I want to do this right now? No. That's not what it is. So if I subtract 3, if I did square both sides, I'd have to square this whole side, and then I would have to FOIL it. So the person that's doing this is being just a little bit optimistic. Right? And optimism normally, very often will lead you down the wrong path, unfortunately. Right? You gotta be careful. No good. But here now I've got my radical isolated. So I think I made my little joke last time about this feels like political science class. Isolate your radical element, and then it's destroyed. All right? So get the radical by itself, and then square both sides. Right? What's the opposite of square root? Square. So if it was a cube root?
Cube.
Oh, cube. Yeah, exactly. I'll do this side. Look at me doing half the work. Ooh, okay.
And the other side, I have the end side.
And on the other side, what do? Is it x squared plus 9?
No.
Yay. Why? You have to do what with this?
X minus 3 times x minus 3.
Exactly, right? Twice. You got to FOIL that bad boy out. So what would you get if you FOIL it?
X squared minus 3 minus 6x plus 9.
Coolness. And this is going to happen a lot because we're squaring things. I should expect this to happen sometimes where I get one x with a square on it and the other x's don't. So of course in that situation, what do I want to do?
What? Can you repeat?
That was a lot I just said. So when I have one x with a square on it and the other x's don't, so I can't get my x's fully together, process do I use?
Factor.
Factor after I
Equal to 0.
equal to 0. So I just have to, beautiful, subtract x, add 1. So on this side I get 0. On this side I get, and thankfully that does factor.
Negative
Right.
2. Negative.
So you guys might realize where we're very soon, where we're headed very soon, which is what do I do if I can't factor it, which is quadratic formula kind of stuff. All right, so that's going to be in chapter 13. So here, this is nice. Yeah, I think I heard some of you guys say it's going to be 5 and 2.
Negative.
Both of them got to be negative. So then I get x is 5.
Equal to
2.
And you just circle that, keep going?
No.
Yeah, no, good. You got to check them to make sure, because the minute you squared both sides, you lost information about the sign of this side. So you might, by squaring both sides, you might have brought in an answer that actually doesn't work back in the original. If that makes sense for you guys. So does 2 equal negative 2? No. But if I square both sides, does 4 equals 4? So this is everything's great, but I know from the beginning, no, it wasn't great. But the minute I squared both sides, I lost information about what was negative, everything looks like it's positive. So math might say, oh yeah, both of these are great for this, but I got to make sure they're great for this too. Right? So they could either both work, neither one of them could work, or one of them could work. So let's see, what happens if you put a 5 in? I get 5 equals square root of 5 minus 1 plus 3.
Yeah, works.
Yeah, what's the square root of 5 minus 1?
4.
So square root of 4 is 2.
Plus 3.
Check. So if I check 2, I get 2 equals square root of 2 minus 1 plus 3. 2 equals
1 plus
1 plus 3?
equals 4.
2 equals 4?
No.
No. So then that's not it. You just cross through it. All right, so make it very clear to me your check and what the real answer is. So we understand that? Because I know that's a part. It's another place where students start to really, really extra hate math. It's like, why does it give me answers that don't work? It's hard enough already. Right, that's what you guys sound. But it's because we did this. We had to do this, but because we did this, we kind of hid something. Math can't see what it was anymore. So these look like they're the answers, but we got to go back and check it. Okay, maybe. That's not too bad, right? Yes.
So, how much credit do you take off if you don't check the answer, but everything else is correct? It has to.
I love that question.
No, I'm just giving you that, because I'm not going to do that. But I'm just saying.
I don't know, about 30 points. I don't know. I have no idea. I have no idea how much everything's going to be worth the next test. I have no idea. Just don't forget, and then you won't have to find out. Worst way to find out how much you're going to lose is to actually lose it. So don't do that. Okay, good. So this is the kind of question I've been waiting for. There were some problems in the previous section, in 12.5, that looked like... Well, first off, remind me, how would I do this? How would I simplify this?
You do the square
Multiply
root of
the
2.
bottom by
Beautiful. Because the square root needs how many things inside?
2.
2. And it currently only has
1.
1. Poor little dude. So then I give him the one he's missing. I multiply by another 2. So I get 3 root 2 over
4.
2.
2.
root 4, which is 2. Alright, so that's the idea of rationalization, right? I call it completing the square. Completing the root. Give it what it needs. So what the hell if I have something like this here? If you've done your homework, you should have seen some things like this. And now I'm curious what the hell you did. So there are examples that show you how to do this. I can't just multiply by square root of 2 anymore, because then that's going to get a square root of 2, and there's still a square root of... I don't want any square roots on the bottom, right?
Don't you still have to get rid of that 3 since it's not under...
I don't have to get rid of the 3 because the 3 is rational. So the whole idea of rationalization is to leave the bottom as a whole number.
That's 12.4 or 12.5?
Off the top of my head, I think it's 12.5.
I think you're talking about 12.5 right now.
Yeah. 12.5, numbers 61 through 70. 61 through 78, actually, yeah.
So would you do the same thing then, add another 2? I mean, you know, like, how you on the top?
Well, if I try to multiply by square root of 2, do you see I have to distribute it? And then I'm really just moving the square root over there. So it's still on the bottom, right? So I pretty much almost have to just tell you what happens. I want something that when I multiply by, it's got 2 terms so that I can cancel the middle. Because the only thing, if I multiply by root 2 plus something, or maybe minus something, this is not going to be a square root anymore, right? What's square root of 2 and square root of 2? It's 2, like we just saw up here. Square root of 2 square root of 2 is square root of 4, which is 2. So I need something here. Now look, in the middle term is where I could possibly get the square root still there, right? So I need something there where the middle term cancels. That sounds a lot like difference of squares. So if this is root 2 plus 3, this has got to be root 2
Minus 3.
Beautiful. So if we multiply top and bottom by root 2 minus 3, let's see what happens. All these. So on the top, you just get 3 square root of 2 minus 9. Is that cool? So at the top, I just multiply 3 by whatever I had to do to the bottom. And on the bottom, I'm going to get 2 plus 3 root 2 minus 3 root 2. Right? We designed it so that the middle term goes away. And at the end, I get minus 9. So I get 3 radical 2 minus 9 over, which is? Suspense is killing me. So is the bottom, is there any radicals on the bottom anymore? So it's been rationalized. It's not irrational anymore. It's been rationalized. So what you call this little dude here, where the only difference is the difference in the sign, you call this the conjugate.
Do you always
Multiply by the conjugate. Yes, sir.
Do you always switch the signs in that situation?
Yeah.
Also,
So if I had, how is it different from your first question? I love it.
wait, for my first question.
Yeah, no. Do you always do it and then all the time? Yes. Sorry, just going through for a second. So if I had something like 7 rad 5 over 2 rad 3 minus, let's make it really yummy, rad 5. No, let's make it rad 7. Yummy. So what will always work when you have 2 terms on the bottom, and either one of them or both of them have radicals in them, multiply by the conjugate. So what would the conjugate be in this case?
2 squared
Plus.
Yeah, 2 square root of 3 plus radical 7. So just remember, it's like it's the difference of squares partner for the dude. So you're kind of giving him what he's missing in a different way. Now that there's 2 terms, you got to give 2 terms to it. And what it's missing is its difference of squares partner dude. That's what we call the conjugate. Yeah.
Does that same rule apply to if you had, instead of it being squared, if it was cubed or...
Cube root?
Was it
That gets really
that
difficult
doesn't
with
work.
multiple terms. You can
You know
imagine.
what I'm saying?
I know what you mean, but that doesn't work the same way. Then you'd have to complete the cube. You'd have to do like a big dude for a cube. No.
Okay.
So we're not going to go there.
Okay.
There's a way to do it, but it's not pretty. So what do you get on the top here?
14?
Yep, 14. Good start.
14 to 15?
Root 15.
7.
7.
12.
12.
Square root.
20. No.
35.
35.
Oh, yeah.
Let's try and get 7 there. Okay. Can you add those together?
No.
Quick answer is no, they're not like terms, right? The long answer is also no, they're not like terms. That is the answer. And then on the bottom, what do you get here? 4 times square root of 9, which is 3. I really want that to be kind of quick for us. If I do square root of 3 times square root of 3 is 3. Square root of 11 times square root of 11 is 11. Square root of m times square root of m is m, right? Shouldn't have to do any intermediate work. So 4 times 3 minus 2 square root of 21 plus 2 square root of 21. Not even going to worry about the middle term there. Because you know it's a difference of squares. I designed it to be that way. And what do you get at the end?
49.
7.
Square root of 49, which is 7. So I get 14 root 15 plus 7 root 35 on the top. On the bottom I get 12 minus 7, which is...
Just I have one quick question.
Sure.
How did you get to 3 or 2 times 3? I just want to know.
2 times 2?
No, that's 40, yeah, obviously.
Square root of 3 times square root of 3?
And then just pretty much, okay, that's 3.
Yeah, because it's square root of 9, which is 3.
Okay.
Yeah. Cool. I know that's not your specific one, I think, but same idea.
Come on, man, my questions are not too bad.
No, it's Carl's question. Let's see. Okay, cool. All right. So we're going to get into section 12.8. And section 12.8 is another place where, I think I gave a little preview of this last time. It was just an unfortunate naming choice. And to be honest, the history of it, they think that he meant to say negative instead of imaginary, the guy that coined the term imaginary numbers. And the great mathematical minds of their time hated them as much as you probably do. But that's because they didn't realize their importance then. Sort of like you guys. So when you first learn about this, you're like, okay, now you're definitely just making shit up, okay? You're actually telling us directly they're imaginary. But again, it's just an unfortunate naming choice. And the idea of complex numbers in general is to go beyond real numbers and start to look at the things we kind of neglected, and we always just say we can't do them, are square roots of negative numbers. So the first little step is a very minor step. It just makes it a lot easier to kind of work with them. So it's just a definition. We're going to define the square root of negative 1. We're going to define it to be I. We're just going to replace that with I, just so it's easier to look at and work with. Now, I'm going to give you a little bit of the history. We haven't talked about this yet, but you all know, I mentioned this earlier, quadratic formula. Everybody's seen that somewhere. Negative b plus or minus blah, blah, blah. Negative b plus or minus square root b squared minus 1. All that stuff, right? Okay. I'll be seeing that old man walk around there like, negative b plus or minus. Pretty much. So there was a dude, the history of mathematics is crazy. There was a guy named Cardano. You should look this guy up. I think his first name is, I forget it now, it's like Gerald or something. Cardano, and he did this, he was really into gambling, and he was doing a lot of mathematics related to games, right? But then he came up with so the quadratic formula is for solving stuff like this. That's what the quadratic formula is for. He came up with an expression that went with the cubes. He could solve an equation with cubes in it. So when he did it, in the middle of it, at the end he'd get answers like 2 and 7 and 4/5 or something. But in the middle of it, he had these things like this floating around. He's like, oh, shit, that's weird. But when you in the middle of it, you had these things. But at the end, they would all kind of go together and make it come out to be a nice number. So it would be impossible to do this work without the idea of imaginary numbers. They show up in the middle of this thing. Right? Now, we don't normally learn how to solve cubes like this because it's a very obscure, weird-looking formula. But this is a beautiful show of why we need to learn about them. They're useful in this way, at least. Complex numbers, you use them with voltages, with studying circuits. You use them in studying electric and magnetic fields. Those are the kind of places I'm used to doing them, using them. It's insane. So complex numbers are important. They actually have a lot of uses. They're not just me filling in the time. Let's talk about weird, complex, imaginary shit. No. They actually have real purpose. The minute I define I to be this, what's I squared going to be?
1.
No.
Minus.
What's the square of the square root 2?
Cancel.
So you're left with?
Absolutely.
Negative 1.
No, just negative 1. That's weird. Because you square root of negative 1. Before today, you would have said not real, or can't do, or no way, or what the hell, right? Well, I'm waiting for someone to say what the hell. You with me? Before today, you would have said that. So, of course, it's not going to act the way I necessarily imagined it would. But the square root of anything squared is that thing. Period. Now, see, that's a very subtle difference between these. Now, what is this? That would be that. There's no question about it. But you see, this one is the square of a square root. They just kill each other directly. Okay, maybe. Do you guys see the difference there? If you thought this should have been absolute value or something, no, it's not this. That's where the absolute value comes from. Here I'm squaring, so the square root just cancels directly. Well, X dude is like, oh, good, it's gone. I'm here, yay. He's not going. Why would he be an absolute value? There's no reason for it. So I know that the part of your brain is balking right now because you're like, you can't square anything and get negative 1. No, you can't square any number that you knew that existed before today. These are the numbers you can square and get negatives come out of them. Yeah.
Yeah, I was just saying that I is still square. So are we done?
Where are we at, sir?
Right, I is still square.
I squared.
Yeah, and so I squared equals minus 1. That's the final answer.
That's it. That's what I squared is. Yep. That's what I squared do be. Okay. So here I got, so making a little list. I is I. That's amazing. So I to the first is I. I squared is negative 1. So what's I cubed? Oh no, Jeff, man.
1.
You just hear you guys. Your brain,
It's negative 1.
what's that?
Negative 1.
No?
1.
I cubed is I squared times I. Is that cool? So whenever you have a power, you don't know what it is. You build it off of powers that you know. I know what I squared and I are, so isn't I cubed I squared times I?
Yeah.
Because what would you do with the power? You'd add them, right? What's I squared? Negative 1. What's I to the first? I, so you get negative I. So I cubed is negative I. I really want you guys to understand, we are kind of learning new numbers today. So it's not a question of, are you able to do something? It's a question of, can you accept this? And if you can accept this, then all of this is a consequence of that. It's got to be. I squared has got to be negative 1. And then I cubed has got to be negative I. All right, how we do so far? So we know that complex numbers, imaginary numbers, exist for a reason. They came out of this work before they even knew about their existence. Right? There were people that saw this and they just kind of like, I don't want to do it. So they didn't look at it. They just said, that's impossible, it can't be done. And then finally Cardano came up and said, they come up here and if I keep going, I get nice answers. Shit, so these have to exist. We should study these weird things. So they have a purpose. What we're doing right now is, okay, here's the definition of it. What does that mean in terms of what it does? So now we're going to start investigating, what if you add two of these together? What if you multiply some of these together? What if you divide them? Right? Because what do you do when you learn numbers? That's what you do. You learn 1 is 2, and then you start going 1 plus 2 is 3. Yay! So that's what you do when you learn new numbers. So what was I to the 4th? Who's got a suggestion how to do that? I love it. I squared times I squared. What's I squared?
Negative 1.
What's I squared?
Negative 1.
So negative 1 times negative 1? 1. And then it kind of starts over again. I to the 5th would be I. It's I to the 4th times I. It kind of cycles through this. The most important thing in this list is this guy. For a couple of reasons. We leave it alone if it's I. If it's I squared, we replace it with negative 1. I've got to know that's true. And the rest of them I can build off of these two. Right? Just like we built right here, just like we built right there. So the most important thing in this list is here. Alright. So that's the imaginary part of things. So the complex numbers are more general. They're built of imaginary parts and real parts. So everything we studied so far, of course, is the real parts. And the background is always these imaginary parts that we never really think about. Just imagining what's going through your heads. All right. So here's the idea of a complex number. Here's what a complex number looks like. So a complex number is a combination of real and imaginary. So I could have a number, for example, like 7 plus 5i. There's the imaginary part. There's the real part. All right, how's that so far? So every number we've seen before today was complex, like the number 11. We've seen that number before. What's the imaginary? Here's the real part. What's the imaginary part?
Plus 8y.
That's 8i.
What must be here since there's nothing there?
0.
0. I love it. 0i. So every number we've seen before today had the imaginary part's coefficient equal to 0. That's why there wasn't anything there. It's like having a y-intercept of 0, right? Just doesn't even show up. Okay, maybe. So in general, these look like a plus bi. So if I make b 0, I get numbers that we're used to. If I make b not 0, we get numbers we're learning about right now. So how are we doing so far? I already know the answer to that question. Yes?
I don't understand where you were going with that. 7 has an RE.
So, I'm sorry, it's real.
Oh, okay.
It's a quick way to write real.
Plus 5i.
And that's imaginary.
Okay, so you're just showing that.
What the real part is, what the imaginary, because complex numbers are combinations of reals and imaginary. So every number we've seen before today is a complex number. It just happened to have b equal to 0. Right? So we didn't even mention that we were in a special subset of the complex numbers, because that would have you would have probably just turned around and went out and said, that's not for me. Right? Thankfully nobody's done that yet. I see it on your faces when you think about it. So let's get some nice news. Here's some good news. And hopefully this isn't freaking the hell out of all of you guys. I mean, this is actually a very... I know it's really easy just to turn off, especially when we say the word imaginary. It's so easy to just go, that's it. Right? But it's insane the number of uses imaginary numbers have. Unfortunately, most of them deal with slightly more advanced math. The one reason why we're getting into these right now, and let me see if you guys can help me out with this. Can we solve this equation now? Totally. We can totally solve this equation. We're not used to being able to solve this equation. What would you do to both sides to kill that square?
Is square?
Square root.
Square root.
Yeah. Now, here's the part that I'm not sure that everybody is aware of. You would have to put a plus or minus here when you do this. So just to remind you guys, let's go back to nice normal numbers. What do I square to get 4? 2 or? Negative 2. So if you actually do the math, you just have to remember, oh yeah, there's 2 possibilities for this. All right. So right there, the minute you take a square root in an equation, you must put plus or minus down to keep track of the 2 options. You know there's 2 square roots for any real number anyway. Now we're seeing this true for when I get complex numbers. So here I'm going to x equals plus or minus square root of negative 9. How can I break this up?
I said it's 3, negative 3.
So more like this. I know the square root of 9.
4 and not 2. Oh.
And what else? What do I have to put here then? Yeah, and so now what is the square root of negative 1? I. And what's the square root of 9? 3.
Say that one more.
Which part, sir?
The negative 1.
So are you cool right here? Are you cool right there? All right, it's okay. It's all right. It's all right. Yes.
We're just getting rid of minus.
To have a square root.
Say again.
Because the original problem was x squared equals -9.
Yes.
And then we moved the
Yes.
x squared.
Good.
Are all the other x's supposed to have the square root too?
No, because what's the square root of x squared?
X.
X, yeah. Or here's another, now real quick, let me do this again. Here's another way to look at this. I don't know if you guys remember, the square root of x squared, another reason why I put a plus or minus there is because, I don't know, do you remember the square root of x squared? What is it really if you have to be careful? I think this is going back to what somebody else was saying earlier. The output of a square root has to be positive, right? So I can't just put x here, I have to put... Alright, now watch. Let's do a couple of problems here real quick. Let's do this one again. If I put square root on both sides, another way to kind of do this, without putting a plus or minus down, is just to say what this really is. What's the square root of x squared? It's absolute value of x. Equals 2. Now what is it? What do you have to do here?
Plus or minus.
X equals 2, or x equals -2. So putting the plus or minus is just kind of a shortcut for that. I know there's going to be an absolute value that comes out of there. So instead of doing that, I just put the plus or minus just to get to the answer more directly. So there's another reason why we put the plus or minus there. Yes, ma'am?
Why do you have, going back there, why do you have square root -1 and then square root of just 9?
Because what is the square root of -1 times 9?
Negative 9.
Square root of -9. So I can break that up. So I know what the square root of -1 is. And I know what the square root of 9 is. Sort of like I know what the square root of 2 is, square root of 25 is, right? But I don't know what the square root of 2 is, but if I had square root of 50, I would break it up like that. Into parts that I can do, right? So all I'm doing here is, I'm going to break up that square root of -9 into parts I can do. I can do the square root of -1, that's a part of it. I can do the square root of 9, that's a part of it. Square root of -1 is I. Square root of 9 is 3. What would the answers have been if it was just x squared equals 9? 3 and?
-3.
Yeah. So the only difference was?
Then I.
Yeah. And all the I is doing there is taking into account that it should come out negative, right? So let's do it the other way. Now watch this. What's 4i times 4i?
16.
Beautiful. 16i squared. I love it. What is I squared?
Negative 1.
-1. So you get -16. You with me? So here the answer was 3, or -3, because 3 times 3 is 9. -3 times -3 is 9. But how do I get -9? I have to have complex numbers. 3i times 3i would be -9. Just like 4i times 4i is -16. And you don't have to just know that. What did you do? What's 4x times 4x? 16x squared. So what's 4i times 4i? 16i squared. And now you see why I said that's the most important thing to know about I, really, is because that's the thing that happens the most often. If it's just I'm going to leave the damn thing alone. Because that's why I made the symbol I. So I don't have to look at square root of -1. But if I see I squared, I'm going to replace that thing right away. So I can see what number it really is.
Does I always pertain to negative?
Square root of -1. That's what I is. I is, and I love the way my grammar sounds like it's horrible when I talk about this stuff. I is the square root of -1. That is what I do be. Alright. So, my whole reason for doing this is, anytime I have an equation with x squared in it is the highest power, I have to have 2 answers. That would be really nice. So if I had a 7th power in an equation, I need to have 7 total answers. If I don't know about complex numbers, I would think there's no answers here. And there should be 2 answers. And we got the 2 answers now that we know about complex numbers. There they are. So if I had an equation with x to the 7th in it, and that's the highest power, that's my equation in it, that's the highest power, there has to be 7 answers. Some of them could be real, and some of them could be truly complex, right, with I parts. If I didn't know about the complex numbers, I would never get 7 total answers. It wouldn't really be a nice fit then. Kind of makes more sense if I get 7 total answers if I see a 7, 11 if I see 11. It's kind of nice. Okay. So let's go, the nice thing I promised you earlier.
As they were doing the beginning.
What do you think this is here? How do you add complex numbers? Am I multiplying them?
No.
No. How do you add complex numbers?
Common denominator?
No, don't go crazy.
Like terms?
Yeah, I is just like X. It has a value, but it's just like X. It's actually, I mean, how would you do 5 plus 2 radical 2 plus 4 minus 3 radical 2? 5 and 4 is 9. 2 of these minus 3 of these is
-1.
minus 1. So this is, I is a square root, right? But it's even better now. I can just look at it like a variable. So how do you add these? You get
9 minus 1.
minus 1i. Yeah. Just like you would get 9 minus x if there was
But
x.
then you know that I is a square.
It's the square root of negative 1.
Do you have to substitute?
Hell no. Never. Never, never, never. That's why we created I, so we don't have to look at that weirdness. But if I get I squared, it's not weirdness. It's just nice, good old negative 1.
Okay.
Now, in reality, I mean, if you put it there, you're not technically wrong, but that's why we made I, so we don't have to work with that directly. So let addition and subtraction of these be simple. It's just like it was an X there, right? Now, you said foiling earlier, so now when I start multiplying these things, what's going to pop out of it they're going to be careful about? I squared. That's the first step is going to be treat it like it's a variable. So how would I do, I multiply these instead? So the first step is good old normal stuff. Alright, good. So you get 20 minus 59 plus 8i
Minus 6i squared.
good, minus 6i squared.
Which is just 6 times -1.
Beautiful, right? So your first step is you don't even worry that it's weird. You say it's a variable I. Whoop-de-doo, right? You just multiply it out. But now I can replace I squared with what it
So
is.
then it would be plus 6.
So I get 20. What do I get there in the middle?
-7.
Minus 7i.
Plus 6.
Good. Plus 6. Is everybody cool with that? It's minus 6 times negative 1, so now it's plus 6.
And then do you add
So
like
it's 13 minus 7, 9.
Careful.
20.
20 plus 6.
Sorry, 14. Oh, 26.
There it is. That's all right.
That's the answer?
That's it. So when you multiply two things that have the form a plus bi, your answer should have the form a plus bi. Right? Okay. All right. So I know this is weird, but I want you to realize the actual mathematics behind this stuff, so far at least, is pretty simple. The only thing that's really, really new is the I squared thing. And that's negative 1, because of how we defined I. Yeah. Oh no. Oh, the battery's low. He's going to keep working for a while. Oh, I forgot to do that. All right. Hey. Yeah, my battery's low. That's good. All right. All right. Let's do another one. Here, you guys try these couple here. course, on the first one, you got to be careful with that minus in the middle. Cool. Minus, what's that square? Yeah, so it's minus negative. There's a minus, and then that's negative. So they should cancel the plus one. Good? So, okay, on this first one, you just have to be careful that this goes through to both. And then you get 3 minus 7i, yeah. Right, you just got to distribute the negative through. That's old stuff, way back to when we learned polynomials. Got to be careful about those negatives in the middle. This is interesting. I'm multiplying this times something. Maybe I would call this the conjugate. In fact, we call this, of course, we call this the complex conjugate, right? Just to be nifty. So if I multiply this, I should come up with a real number. It should cancel all the radical weirdness. That's the idea of a conjugate. So sure enough, I get 36 minus 6i plus 6i. Minus I squared, so it's 36 minus negative 1. Good. Which is neat. Completely complex comes out nice and real. Which leads us to problems like this. Let's see. Thank God. If I had this,
Multiplied by the
yeah, multiply the conjugate. All right, so how do you divide complex numbers? You end up having to multiply by the conjugate of the bottom. The same way we did earlier with the radical 2 and radical 5 and all that stuff. Exactly the same idea. So I would multiply by what?
6 minus i.
Good. Times 6 minus I. Get in there. There it is. So on the top I get 6 minus I. That's neat. And on the bottom, of course, I get
1.
You had before, 37.
37. Right? Well, 6 times 6 is 36. Then cancel, and then minus negative 1 plus 1.
37.
But
37.
if you didn't know that, you would just FOIL and do it.
Of course. You would do this. But we just happen to already have done that. Yeah. And I could write this. Now, this is fine. If you stop right there, I'm okay with it. But if you go one more step, 6 over 37 minus I over 37. The only reason I would do that is because anytime I do an operation on a complex number, the answer has to be a complex number. What does a complex number look like? A plus bi. Sure. So here's A plus bi. And b would be negative 1 over 37. Do you see that? So I have to be able to write it in the form A plus bi, or else I did something wrong.
Even if the real number is a decimal or something?
Of course, definitely. In general, A and B can be any damn thing you can imagine. So A could be the square root of pi, and B could be 1 over, I don't know. What do you got? 1 over 3.4 to the 18th power. There you go.
For both answers are okay, though, right? Those are alright?
Yeah, you stop there, I'm okay, but I just want you to realize
That's better. That's
one more step is a little bit better because it's now in the form A plus bi.
Okay. So
I'm not going to be extra picky on this stuff because this is brand new to us.
So were you saying you can't write 1 over 37 to I?
Yeah, so I mean, if you wanted to,
Yeah.
like you're doing a slope, pulling that n out, right? Okay, but you can stop right there. That's fine. As long as the bottom becomes real, you're okay.
But the bottom doesn't always come real, or it has to.
Has to. If I do a complex conjugate,
It has
there's
to.
no way it can escape becoming real. I love it. It's a phrase you don't hear very often is when your bottom becomes real, then you've done the conjugate correctly. All right, so you guys try this real quick. It's like a difference of squares. 11. And so you got 16 minus 9 times, what's I squared? Beautiful. So you just put a negative 1 right there next to the negative 9. Because I squared is negative 1. So what do you have left? 16 minus 9 times negative 1. Because you're just replacing I squared with what it is. Beautiful. 16 plus 9. Yeah. All right, so what are you going to multiply this by?
4 minus 3.
So on the bottom you get 16. The middle terms cancel.
Minus 9i.
Good, minus 9I squared. Squared. On the top I get 20.
Minus 47.
Yeah, good. Minus 32 minus 15 is minus 47I. Plus 24
I squared.
I squared. So now the next step, that now is when I worry about I squared and what it really is. So then I can do 20 minus 47I plus 24 times
Negative 1.
negative 1 over 16 minus 9 times
Negative 1.
kick ass. And now you just put your like terms together. 20 minus 24.
Minus 4. Minus 4.
Alright, and then you got the minus 47I.
25.
And 16 plus 9, 25. Cool.
Close.
The ballpark. You're going to see how to do that. Okay, maybe. It's going to take a little while to sink in. You've never been able to replace x squared with negative 1, and all of a sudden we're doing something like that. But we know I is not like x, really. It has a value to it. Okay. So here's... we already saw one reason why we learn about complex numbers, because we could have an equation like x squared equals negative 64. And how would you solve that?
Square root.
Square root.
Would be 8.
I'm still saying it's not
Plus and minus.
So you get x equals plus or minus
8.
pretty.
Minus
8i. Since the square root of 64 times square root of negative 1. So the square root of 64 is 8. The square root of negative 64 is 8i. Square root of negative 25 would be 5i. Square root of negative 49 would be 7i. It's crazy, man.
The negative is always the I.
Good, because there's a negative inside the radical. I can always pull a negative 1 factor out. That's going to become what we call I. So let me show you one little side note. This is, I'll just tell you straight up, this is going a little bit beyond. So yeah, this is not open for vote. I'm going to show it to you no matter if you want to see it or not. We used to not be able to factor that. Now we totally can. And the reason we weren't able to factor it before is because whenever I multiply something by its opposite, because x squared minus 49 can be negative 7 and 7, but when I multiply them, I get minus. And I've got a plus there. But now my I, if I get negative I squared, that becomes plus. So I can totally do this. So it would be x, but it won't be 7, 7i. Let's check it. X squared plus 7ix minus 7ix, and then what's this? Minus 49 I squared.
Which is negative.
Which of course becomes that because I squared is -1, right?
Oh, wow.
So you can only factor a sum of squares if you're allowed to use complex numbers.
So way back when I factored 49, you can get a wrong answer. You should go back and correct that.
No, Carl. No, I can't do that because you can only use what you know at that point in time. It's a good try. I appreciate that. Because I don't think you put an I there, did you?
I think I get confused because they told me that over the thing.
Oh, no. All right. I like that. All right. So, if we ever have an equation like that, that's the quickest way to get the answer. That plus or minus is actually what allows me to not have to do the factoring, right? I mean, I could have added the 64 over and then factored just like we did there. And then I can get my two answers, bam, bam, right? But if I just do it this way, I don't have to look at it like I'm factoring something. And it's a little bit easier for us to handle because it's been so drilled in our head, you can't factor sum of squares, you can't factor, now all of a sudden you can. Okay, so what about this here? It's not making too freaky sense. They have to actually fight your initial urge, which might be, if your initial urge involves foiling of any kind, it's not the right thing. I can do this much more directly. Square root both sides. I got more stuff inside the square, but I can still just kill it directly. Because everything's been collected for me. So if I take a square root right now, and the minute I do that, I put minus. That square and the square root cancel. So then on this side, I'm left with
X minus 4.
and over here I get plus or minus. Now we're going to do this. What's the square root of 11? Square root of 11, I don't know. What's the square root of -1?
Yeah,
Now be careful. Always put the I in front, because if you don't, it might look like it's inside the radical. And can you even start to wonder what square root of I is? Do you want to start to wonder what that is? No. In fact, I can't even teach you that unless you ever got to pre-calculus. I'm going to teach my students that tomorrow, what the square root of I is. So don't worry about that. Just always put that out front, so you're very clear that you're like, I'm not doing something weird as hell. I is not in the square root. You with me? The book kind of shows you to do it either way. That's stupid. Always put it out front.
So it's like you're playing up the negative.
Exactly. If I break this up into square root of -1, square root of 11. Square root of -1 is I. Square root of 11 is I don't know. Square root of 11.
So,
How do you solve for x? I'm not done here yet, right? Add 4. Yeah. So x equals, I'm going to put that right in there. 4, give or take, I, or add 11.
how do you know when the part goes?
It doesn't matter. If you wrote plus or minus I, or add 11 plus 4, you would be right. Just writing that almost kind of hurts me a little bit. It's just convention to put that out front.
I put 4 I.
Sorry?
For I.
But is the 4 multiplying by this?
That's what I was just gonna
I'm adding the 4, so I can't put it there. I'd have to multiply it to get it there.
4 plus or minus.
Okay.
Yeah, so it's 4 plus or minus that. Yeah.
You can't do anything with the I because it's connected to the square root.
Exactly. Unless I was multiplying or dividing by something, then they could go together. I like that. We got plenty of time. Thank you for pointing out. Yes.
I have a question.
Yeah.
What if, in this case, we have -11? What if we have -20? Do we have to break
Yeah,
it?
good. I love it. So if you can simplify the radical, you must.
Oh,
So, for example, let's see. Oh, well, good. This will be fine. Not everything in the world has to be complex.
So, in this case, we'll have to move the 7.
Good, I love it. So just like we learned earlier, you had to isolate the radical, isolate the absolute value. You always isolate where your x is stuck. Because if I try to take a square root right now, I can't do this. I can't take the square root of each piece. So I have to get that over there. So if I move that 7, does everybody see that?
Square root.
General rule in algebra is isolate wherever your x is stuck. So then you can unstick it directly. Undo the operation that it's stuck in.
Square root.
Cool. I figured I'd give us a break from imaginary stuff for a second. Not all the things are going to come out imaginary all of a sudden now. It's just every now and again they could.
So now we're multiplying x plus 7 twice, correct?
No, yeah. That would be the long way. You square it, and then you pull the 18 over, and then you know guaranteed that it's going to factor. In fact, it wouldn't.
But we don't have negative 18 there, so there's...
It's fine. It's no complex number. I don't want you to suddenly think that everything we're going to do is complex.
Okay.
It's just if it comes out negative, you're going to get an I. If it doesn't, you're not.
Okay.
So you won't go square root from this point?
You definitely want to kill that, so I have to do a square root.
Okay, this way.
And then I have to immediately also
Well, minus.
plus or minus.
You do have to have plus or minus?
Totally, definitely. And that was nothing to do with the fact that it was a negative number. It's got to do with the fact that I'm taking a square root, and there's always two options. Yeah.
I think I understand. I think her question is when do you know whether to factor or when?
Oh, yeah, sure. So in the past, before we learned this, before we learned about radicals, if I had an equation like this, I'd have to square it and then pull the 18 over. But now that we know about radicals, I could directly kill that too. If that wasn't there, I would just subtract 7 and be done with it, right?
Yeah.
So if I had a way to kill that squared, I totally would, and I totally do now, right? So when it's already together like this for me, and the next thing we're going to learn is how to make it look like this if it doesn't already look like this. If it's already together like this for me, I can just immediately take a square root. Because that would get the x ready to get by itself, right? Right now I can't subtract 7 because it's stuck. But if I take a square root, I get that on this side. Is that cool? Does the square and the square cancel? What do I get over there?
Square root, plus or minus square root. Put 3 on the outside.
Good. Because this is 9 times 2, right? So square root of 9 is, square root of 2 is, yeah. And then the last step,
Subtract the 7.
beautiful. And you do try to squeeze that bad boy right there. So you get x equals, so that should be the answer. So if you did multiply this out and then subtract the 18 over, you would never in a billion years be able to factor it because your answers are supposed to be this. You ain't going to factor it like this, are you? No, it ain't going to work. You'd have to use quadratic formula. We haven't learned that yet.
But Jeff, we have the question right there, 11 doesn't factor, so we just leave it the same number.
Beautiful.
Right?
But then the question, and really your question was, what if I can do something? Then yes, you must. Yeah.
In that answer that we just got, would you be able to do minus 7 plus 3 and minus 7 minus
Good. I'm glad you're saying that. Everybody realize that there are two answers here, right? There's negative 7 plus 3 rad 2, and there's negative 7 minus 3 rad 2. I love it when a student comes up and asks me, where's the plus or minus key in the calculator? You do one at a time. So if I wanted a decimal for each of those, you would put in your calculator negative 7 plus 3 times rad 2, and then you put the other one, negative 7 minus 3. There are two answers there, right? And why does it make sense there's two answers? Because the highest power I saw in my equation was 2. I expect two answers. There has to be two answers now that we know about complex numbers.
So just put the plus and minus is that a good
So would it be x equals?
No, it is. It's totally that's circle. But that's just what that means.
Oh.
Make sure everybody understands that is two answers. Yeah.
So would it be x equals negative 10 square root 2 and x equals negative?
No, totally not. Because can you add before you multiply? So these are not like terms, so you can't put those together, right? Notice something. How do these things relate to each other?
the real number?
Opposite plus and opposite.
So they are
Conjugate.
conjugates of each other always. Your answers to these kind of problems will always be conjugates if they're radicals or complex. There will always be conjugates. Just
Now, we didn't use the imaginary number just because we didn't have minus inside the root.
Beautiful.
Right.
It was a positive 18, so there's no reason for I to show up. I don't want you to get stuck in that mindset. It's only if you happen to be taking the square root of a negative number. If you're not, don't throw an I in there, right?
And if we wouldn't have imaginary that number, it would just have a -1, right?
It would just have an I in it. If it would have been a negative 18, the only difference would have been I. That would have been the only difference.
3I square root of 2.
Alright, so let me see if I can do this last piece.
It'd be 3 square root
Alright.
So
So if it's in this form, easy. Easy peasy. Right?
What's that number? Right?
Equals a number. I don't care what number, right? Equals any number you want to. I can solve that. You put any number there, we can solve it now. Doesn't matter. Right? We can handle negatives, we can handle positives, we can handle decimals, we can handle fractions, whatever. So if it doesn't look like this, what the hell? So let's investigate this from the other way. So I want to take something that looks like that and make it look like that. Because if I can make that look like this, I could just take the square root of both sides and be done with it. Can you factor this? Factors of 7 that make 4?
No.
Hell no. So please, dear God, we got to come up with a way to do it. Right? We don't know how to do this, but I do know how to do it if it looks like this. So if I can make that look like this, then I can do this. Right? Oh, Matt TV, I missed that. You look up there. So how do I do it? So the way that we develop a process for doing that is we kind of start from where we want to end up at, and we investigate how we get there. So what I'm saying is, if I add x minus 4 squared, what would you get when you FOIL that out?
x squared minus 4.
4x and 4x?
Yes.
8x. So the middle one is twice that last dude, right?
Plus 16.
And the last one is that guy squared. Right? And of course, if you think about it, of course it is. You're going to get the middle one for minus 4x minus 4x. So it's going to be twice whatever that dude is. And the last one's going to be this times itself. Right? So let's test it again. What's x plus 7 squared? X squared. 14 is twice again. Plus 49. I love it. So, what that means is, now I want to go the other way somehow. I want to start with something that's missing something and figure out what to put there so I can do it like this. What the hell did I just say? This is what I'm saying. So if I had x squared plus 6x, my purpose is to try to figure out what do I put here so that it will become something squared like that. So the steps are, how do I figure out what 4 is if I didn't know what it was? I know that that is twice this, right? That middle number is always twice this dude, just because of the way that FOIL works, right? Don't let that be weird. Of course it is. Of course it is. So whatever's in the middle, it's twice what I want inside.
3?
So the first step in this two-step process of completing the square is to just take half of that middle dude. So half of 6 is 3. So that's what's going to end up here. And then the second step, what is this number? How is it related to this? Always?
The double.
Not doubled.
Twice.
Squared. So the second step is, whatever you just got, squared. So that's the number that's got to go here. And is that true? Is that true what I just finished writing up there?
Yes.
Totally, yeah. So one more. We'll call it 8. So if I had x squared minus 12x, what would I have to put here to make it factor correctly like I wanted to?
6.
So the first step, good. The first step, but careful. What's in the middle? Negative 12. And I do what to that?
6.
Cut it in half. So that's what's got to go here. What's really kick-ass about this process is you don't actually have to factor anything. it tells you what number to put in the answer. And then the
36.
yeah, so the second step is whatever I just got, I square it, and that's what I put there. And is that true?
Yes.
Hell yes. So let me give you this, and then I'll let you guys out. Give you something here. You guys are so excited. I just said let you guys out. Okay. So here, all right, the title, I took it from an old Math 110 thing, and I forgot to change it. So it should be Math 103. So don't freak out. Yeah, Math 896, multivariable complex analysis. No, it's not good. Remember to change the section number. I just forgot to change it.
So this is all homework?
What's that?
This is homework test or quiz?
No. Yeah, this is the process we just stepped through. So first thing next time we'll look at that handout.
So we're gonna have quiz on Thursday, right?
Oh, yeah, the quiz on Thursday is going to just cover 12. It says 12.6, 12.5, 12.6, 12.8.
12.5 and 12.8.
Yeah, so it's not going to include 12.8 obviously because we just did that today. So it's going to be 12.5 and 12.6. Say again? 6 and 5. Sure. What's up? Oh no, you just turned that in. You're fine. I mean, obviously I didn't put that in until just now, so you're good.